In this video, we're going to decompose an improper fraction before we integrate. And so this is improper because we have cubic, a higher power in the numerator than the denominator, which is quadratic. That's what improper is indicating. If we're dealing with an improper fraction, we need to use long division before we attempt our partial fraction decomposition. So we need to make this have a proper fraction portion of it. So when we're dealing with long division, we take our divisor, which is what's in the denominator, x squared minus 2x minus 3. And then under the house goes our dividend, making sure that we pay attention to or use any placeholders as necessary. In this case, it's not because I've got cubic, quadratic, linear, constant, 3, 2, 1, 0. But if I was missing one of those terms, I might need to have a 0 placeholder in that position for that value. So when we're doing long division, we say, well, how many times does x squared go into 2x cubed? So I'll say 2x cubed over x squared. That leaves me with 2x, which is linear, so I write that above my linear term. We take that 2x and we multiply it by our divisor, which goes underneath. So I have 2x cubed, 2x minus negative 2x is negative 4x squared. 2x times negative 3 is negative 6x. And of course, we subtract all of this. Now, your first two terms will always cancel if you're doing this right. So 2x cubed minus 2x cubed. Then I have negative 4x squared minus negative 4x squared. And it just so happens in this problem that those cancel as well. So negative 1x minus negative 6 minus a negative 6 is plus. So negative 1 plus 6. This leaves me with positive 5x. And then we bring down our last term, minus 3. So again, I look at dividing x squared into 5x minus 3. Of course, I can't divide 5x by this x squared, so we know we're done. And by done, I mean done with the long division part. So we can take our rational integrand that we originally had, and now we can rewrite that. This is now equal to the integral of my quotient, 2x, plus my remainder, which is 5x minus 3, over my original divisor, which was x squared minus 2x minus 3. So what I've done here is I used this process of long division to, factor out or unadd out this 2x, and now I have this as a proper fraction, and I can use my traditional partial fraction decomposition for this proper fraction. So just looking at this piece, we're going to do a little scratch work here. I have 5x minus 3 over x squared minus 2x minus 3. This is my denominator. And of course, I can factor that. That factors to x minus 3, x plus 1, which gives me a over x minus 3 plus b over x plus 1. And if I run through my partial fraction decomposition, or a little bit of work, I'm just going to say, hey, we get a equals 3 and b equals 2. I'm going to encourage you to pause the video right now and make sure you can do that. I'm going to pause the video, write out my work for how I got that a and b on the screen, and then we'll continue with our problem. So here I have on the screen what happens when I multiply by my LCD to clear the fractions. Then I set up my system of linear equations, isolating A in terms of B. I sub that into the other equation. I can solve and get that my B value equals 2. And then substituting that back in, I get A equals 3. So pause, make sure you understand that. I'm going to continue on with our problem. What we have for this part of the fraction here is I've now going to erase and sub that in. I've got A equals 3 and B equals 2. So I have a 3 value here and a 2 value there. This guy is now equal to these two terms. So I have the integral of 2x plus 3 over x minus 3 plus 2 over x plus 1. So at this point, I've done my long division, and then I did the partial fraction decomposition for what was left, and that allows me to have this integrand that's very easy to integrate. So I'm going to split this up into little integrals. I have the integral, or 2 times the integral of x dx, plus 3 times the integral of 1 over x minus 3 dx, and plus 2 times the integral of 1 over x plus 1 dx. So that first term, integrating that, I got x squared over 2. And of course, these 2's cancel. So this first term here that we're looking at just becomes x squared plus 3. Our second piece, we'll integrate this using a u substitution. So I'll say let u equal x minus 1. That means du equals 1, du dx equals 1, so du equals dx. We are dealing with the integral of 1 over u du, or the natural log of the absolute value of u plus c. So by that u substitution, we end up with the natural log of the absolute value. We subbed in x minus 3 for u. And we have plus 2. This last piece here, again, when I do my u substitution, it's going to be very similar. I've got the natural log of x plus 1. And of course, all those 3 arbitrary constants add up and give us a singular arbitrary constant. So in this video, we had to do a little bit of long division before we could decompose our partial fractions. But once we did that and we decomposed our partial fractions, the integration was quite simple. So this is just one of our many strategies we use for integration. And the only way to get better at determining how to choose which strategy to use is by practicing and seeing lots of examples. As always, email me if you have any questions.